Hey everyone, welcome to the channel. Are you ready to unlock the incredible power of C++? It's a language that can seem a little intimidating at first, but trust me, with the right guidance, you'll be writing efficient, high-performance code in no time. In this comprehensive guide, we're going to break down everything step by step, from setting up your very first C++ program to diving deep into object-oriented programming and beyond. No prior experience is necessary, just a willingness to learn and a passion for coding. So, whether you're a complete beginner or you've dabbled in other languages, get ready for an exciting journey into the world of C++. Alright, before we write a single line of code, let's get you set up with the tools you'll need. The first thing you'll want is a C++ compiler. Think of it as the translator that turns your code into something your computer can understand. There are several great options available like GCC and Clang, which are completely free. Once you've got your compiler installed, you'll need a place to actually write your code. You can use a simple text editor, but I highly recommend an integrated development environment or IDE. IDEs like Visual Studio Code or Code Media, screenshots of Visual Studio Code, code blocks in use, programmer using an IDE. Blocks offer features like code completion and debugging tools that will make your life a whole lot easier. The most important thing is to get started. You can always experiment with different compilers and IDEs later on. Now, with your environment all set up, you're ready to dive into the exciting world of C++ programming. It's time to write some code. We'll begin with the classic Hello World program, a rite of passage for any aspiring programmer. Don't worry, it's much simpler than it sounds. In your IDE or text editor, type the following code and I'll explain what each part means. Let's break it down. The first line is like importing a toolbox of pre-built code that lets us interact with the console. The part is the heart of your program. It's the starting point for execution. Everything inside those curly braces is what your program will run. This line is where the magic happens. It tells the computer to print the text "Hello World" to the console. Save your file, usually with ACPP extension, and then compile and run it. If everything went well, you should see "Hello World" proudly displayed on your screen. Now that you've dipped your toes into the world of C++, let's dive into some fundamental concepts. In this chapter, we'll explore variables, data types, and operators, the essential building blocks of any C++ program. Think of variables as containers for storing information. In C++, you need to declare a variable's type before using it. Common data types include for integers, for decimal numbers, for characters, and for Boolean values, true or false. Let's say you want to store a user's age. You would declare an integer variable like this. Now the variable holds the value 25. Operators allow you to perform operations on these variables. Understanding data types and operators is crucial for writing meaningful C++ programs. In the next chapter, we'll see how we can use these concepts to make our programs more dynamic and interactive. In the real world, we make decisions and repeat actions based on certain conditions. Similarly, in programming, we use control structures to dictate the flow of our programs. C++ provides us with conditional statements like, and to execute different blocks of code based on whether a condition is true or false. For instance, you might use a statement to check if a user's age is above a certain limit before granting access to a feature. Loops, on the other hand, allow us to repeat a block of code multiple times. The loop is perfect for iterating over a specific range of values, while the loop continues executing as long as a certain condition remains true. Instead of writing the movement code 10 times, you can use a loop to repeat it efficiently. Mastering control structures is essential for creating programs that can respond to different situations and perform complex tasks. In the next chapter, we'll explore functions, a powerful way to organize and reuse your code. As your programs grow larger, it's important to write clean, organized code that's easy to maintain. That's where functions come in. Functions are like mini-programs within your main program. They allow you to encapsulate a specific task into a reusable block of code. For instance, if you need to calculate the area of a circle multiple times in your program, you can create a function called that takes the radius as input and returns the calculated area. This way, you avoid writing the same logic repeatedly. Functions can also take parameters, input values, and return values, output. By dividing your program into smaller, manageable functions, you make your code more modular, readable, and easier to debug. In the next chapter, we'll move on to one of the most important paradigms in modern programming, object-oriented programming. Object-oriented programming, or OOP, is a powerful way of thinking about and structuring your code. Instead of focusing solely on procedures, OOP emphasizes objects, entities that have both data, attributes, and behaviors, methods. In C++, we use classes as blueprints to create objects. Think of a class as a template for a real-world entity. For example, you could have a class with attributes like and methods like and. OOP introduces key concepts like encapsulation, inheritance, and polymorphism. By embracing OOP principles, you can write more modular, reusable, and maintainable code. It's a paradigm shift that will change the way you approach programming. Let's delve deeper into two fundamental pillars of object-oriented programming: inheritance and polymorphism. Inheritance allows you to create new classes, known as derived classes, from existing ones, called base classes. The derived class inherits the attributes and methods of the base class, promoting code reusability and a hierarchical relationship between classes. For instance, you could have a base class and derived classes like and, each with their unique characteristics. Polymorphism enables objects of different classes to be treated as objects of a common type. This is achieved through function overriding and virtual functions, allowing the program to determine the correct method to call at runtime. By mastering inheritance and polymorphism, you unlock the true potential of OOP, creating more flexible, extensible, and maintainable code. The Standard Template Library, or STL, is a treasure trove of pre-built components that can save you countless hours of development time. It provides a collection of templates for commonly used data, structures, and algorithms. Data structures are like containers for organizing your data. The STL offers a variety of data structures, including vectors, lists, queues, stacks, and maps, each optimized for different use cases. Algorithms are pre-written functions for performing common operations on data such as sorting, searching, and transforming. By leveraging the power of the STL, you can write more efficient, concise, and maintainable code. It's like having a team of expert programmers at your disposal, ready to handle the heavy lifting. Congratulations, you've learned the fundamentals of C++. Now it's time to put your knowledge into practice and solidify your understanding. The best way to become proficient in any programming language is to write code, experiment, and build projects. Start with small coding challenges on platforms like LeetCode or HackerRank. These platforms offer a wide range of problems from beginner to advanced to test your skills and help you identify areas for improvement. Once you feel comfortable with the basics, embark on small personal projects. Think of something you'd like to build: a simple game, a calculator, or a program to automate a repetitive task. Working on real-world projects will not only enhance your coding skills, but also boost your problem-solving abilities and creativity. Remember, learning to code is an ongoing journey. The world of programming is constantly evolving, and C++ is no exception. New standards, libraries, and best practices emerge regularly. To stay ahead of the curve and continue growing as a C++ developer, it's crucial to embrace continuous learning. Stay updated with the latest C++ standards such as C++11, C++14, C++17, and C++20. Each new standard introduces exciting features and improvements that can enhance your code's performance, readability, and maintainability. Join online communities, forums, and discussion boards dedicated to C++. Engaging with fellow developers allows you to share your knowledge, ask questions, and learn from the experiences of others. Embrace the process of continuous learning, and you'll be well equipped to tackle any programming challenge that comes your way. Congratulations on reaching the end of this C++ learning adventure. You've taken a significant step towards mastering one of the most powerful and versatile programming languages out there. Remember, the key to success is consistent practice and a thirst for knowledge. As you continue your coding journey, keep exploring, experimenting, and pushing your boundaries. The possibilities with C++ are limitless. From game development to operating systems, from embedded systems to high-performance computing, C++ is behind countless innovations that shape our world. So keep that passion for coding alive, and who knows what incredible things you'll create.